Hey guys, welcome back. Today we're going to be discussing intermolecular forces. So first, what are intermolecular forces? Well, intermolecular forces are attractive forces between molecules. They're significantly weaker than covalent bonds, which are intramolecular forces. Now, let's talk about the 5 main types of intermolecular forces. So first, we have ion-ion intermolecular forces, which is simply when a positive ion and a negative ion are attracted to each other because of their opposite charge. This is the strongest type of intermolecular force. Next, we have ion dipole forces, which is when an ion, whether positive or negative, is attracted to the opposite charged side of a polar molecule. This is not as strong as ion-ion forces, but is stronger than all the other types of intermolecular forces. But you might be wondering, how do you determine if a molecule is polar? Well, let's take a look at something like H2O, or water. The difference in electronegativity between hydrogen and oxygen is greater than 0.4, meaning that these are polar covalent bonds. Additionally, there are lone pairs, aka 2 electrons, on this side or the oxygen side of the molecule. This means that not only are the bonds pointing this way, but also the oxygen has 2 lone pairs, meaning that this side of the molecule is negative, while the other side is positive. We use the delta symbol because the molecule is not completely positive on the oxygen side and completely negative on the hydrogen side. It's simply partially positive because of where the electrons are and the polar bonds. This is why we use delta negative and delta positive to signify that it is only partially charged. Now let's talk about dipole-dipole. This is simply when one partially positive side of a polar molecule is attracted to one partially negative side of another polar molecule. In this instance, the partially positive side of H2O, or the hydrogen, is attracted to the partially negative side of H2O, or the oxygen, between these 2 separate water molecules. Now, there is a special type of dipole-dipole, and it's called hydrogen bonding. This is when hydrogen intermolecularly bonds with the 3 following elements: nitrogen, oxygen, and fluorine. Essentially, if you see H-bond, or hydrogen bonding to one of these 3 elements, then that is hydrogen bonding. Hydrogen bonding is stronger than dipole-dipole. Now let's talk about dipole-induced dipole. This is when a charged ion intermolecularly bonds with a molecule that is not actually polar, but the charged ion causes the nonpolar molecule to have a dipole-induced dipole. This means that although it's not polar by itself, when coming in contact with a charged ion, it develops a negatively charged and a positively charged side. This is because the electrons move towards this side of the molecule, or the delta negative side, to intermolecularly bond with the positively charged ion. Lastly, there are London dispersion forces, which are typically the weakest of all of the intermolecular forces, if they're on their own. What do I mean by this? Well, London dispersion forces are when 2 nonpolar molecules are essentially in space, and the electrons are constantly moving around. So, for a very small moment, let's say the electrons on this left nonpolar molecule tend to shift over to the left side, purely by chance. Because of this induces a dipole into this other nonpolar molecule, since it sees that there are not many electrons here, aka this is a positively charged side of this nonpolar molecule, causing the electrons to shift like so that the delta negative side is bonding with the delta positive side. These are dipole moments when nonpolar molecules are able to form temporary dipoles. Now, I did say these are the weakest of the intermolecular forces. However, if you have enough of them, aka if the molecules are large enough, they can compound and be very, very strong. And that covers the 5 main types of intermolecular forces. Thanks for watching. Like and subscribe.